Assalamualaikum and good morning. We are from KA03. Today we are going to present our FYP project, which is alternative substitution for mortar paste polyethylene terephthalate. So we're going to start off with the introduction. So we're going to start off with the project background. So the main problem that we often see with the mortar finish is that they have holes or cracks because they are not durable enough. The composition of mortar paste, which only consists of cement, sand, and water, can also be the cause of the floor finish not being able to withstand any large impact. So this project is to aim to improve the mortar paste composition by introducing PET as an alternative substitution for sand.
Lisa. Today, I want to talk about chapter 1 in problem statement. As a floor finish, mortar paste is widely used in schools. Gaps are caused by this contains poor durability. The floor finish may not be able to sustain a significant impact due to the mortar paste composition, which is just includes cement, sand, and water. For instance, the floor will exhibit cracks when there is heavy lifting or work. Therefore, the purpose of this study is to modify the mortar paste composition by using PET in place of sand.
So this is our three objectives. Objective 1, to determine the optimal percentage of the PET for mortar paste substitution. Objective 2, to evaluate the performance of PET for mortar paste substitution. Objective 3, to propose the hybrid mortar paste to school.
For significance of study, first, demonstrate a dedication to sustainable and responsible waste management by utilizing PET waste. Second, helps decrease plastic waste, especially from bottles and containers. Third, the project has proven that PET can improve heat resistance and insulation in construction materials, leading to energy-efficient buildings and a smaller carbon footprint in the construction industry. For significance of study, first, demonstrate a dedication to sustainable and responsible waste management by utilizing PET waste. Second, helps decrease plastic waste, especially from bottles and containers. Third, the project has proven that PET can improve heat resistance and insulation in construction materials, leading to energy-efficient buildings and a smaller carbon footprint in the construction industry. For scope of study, this study examines the composition and properties of mortar paste used for non-load-bearing structural purposes, such as floor finishes. Additionally, it investigates the significance of PET waste in the construction industry by exploring its sources, characteristics, and potential uses or recycling methods. The evaluation primarily focuses on testing the strength and heat resistance of the mortar paste and PET waste materials, providing valuable insight into their mechanical properties and performance in different temperature conditions.
For our expected result, we have fulfilled first objective, which is PET performance in mortar paste, match existing mortar paste, and we need to achieve objective second objective, which is determine optimal PET percentage for mortar paste substitution, and the last one is propose hybrid mortar paste to nearby schools for which for who.
Let's continue to the literature review.
History of mortar. Mortar paste is a mixture used in construction to hold bricks and building blocks together. It is made of Portland cement, sand, and water, but can also include additives to enhance its qualities. These additives can make it resistant to freezing and thawing, speed up or slow down the curing process, or make it easier to work with. The proportions of the ingredients can be adjusted to create different types of mortar for specific construction needs. Choosing the right mortar is crucial for the stability, durability, and appearance of masonry structures. Classification of mortar. There are two types for mortar type S, structural and veneer. Structural S have high workability and can be used above or below ground with block, brick, and stone. Veneer S are better for scratch coats, bond coats, and joints but can only be used above ground. This is a type of non-structural veneer that can only be used above ground and has good workability. M-type is a very strong material that is often too difficult to use for most repairs. It is typically used below ground level. Type O is a non-structural mortar that is primarily used indoors for repointing and repair projects. Type K is a type of material that is specifically used for restoring historical structures. It is gentle enough to be used on old brick and stone. For the performance evaluation, scientists have done a lot of research on how plastic waste can be used in making a special kind of building material called mortar. They look at things like the size of the plastic pieces, how heavy they are, how much water they soak up, and how they are spread out. They use special tools to measure these things, but sometimes they use different methods. This information is from an article written by Saika and De Brito in 2012.
In chapter 2, I need to talk about properties of PET, which is PET characterization and application in construction. PET is renowned for its high tensile strength, durability, and resistance to impact and mechanical stress. It is lightweight, cost-effective, and has strong oxygen and carbon dioxide barrier qualities. PET is also highly recyclable and is used for environmental and sustainable area. In construction, PET is used in concrete construction to create green concrete, and it provides information about concrete's behavior and mixing design data. It's also used in construction, reducing the amount of cement used in cement making. In waterpiece, to reduce the carbon footprint of concrete, some cement can be replaced with PET-based powder. The mechanical properties of PET were significantly changed by wire radiation compared to non-irradiation waste. Using PET waste to replace a portion of cement greatly decreased the amount of strength loss. For
Application of PET. PET is a versatile material widely used in various industries. In the packaging industry, PET is commonly used to make plastic bottle and container for beverage, food, personal care product, and home chemicals. Its transparency allows consumer to see the content, making it perfect for product display. PET lightweight design save on transportation costs, while its robustness ensure product protection during handling. In the textile industry, PET fiber are used to make polyester textile. These textiles have many benefits including high strength, wrinkle resistant, and the ability to preserve form and color. Polyester is commonly used in clothing such as shirt, dress, and athletic wear, as well as in home textile like curtain. The automotive industry also benefits from PET. It is stainless fuel used in the production of vehicle components such as bumper, fender, and interior part. PET lightweight nature contributes to fuel efficiency and vehicle weight reduction. Its impact resistance, dimensional stability, and ability to withstand adverse weather conditions make it suitable for both exterior and interior automotive components. PET is widely used in electrical and electronic industry for insulation purpose. It is commonly used to make electrical tape, cable insulation, and flexible printed circuit. PET excellent dielectric characteristic make it an ideal choice for insulating electrical component. Its thermal stability allows it to withstand the heat produced by electronic cables, ensuring the safe operation of electrical and electronic equipment. Finally, in the medical industry, PET is used to make containers that ensure integrity and safety of medical products. Pill bottle and medical packaging made from PET have chemical resistance, prevent the interaction between the container and the content of preserving the efficiency of the medicine. PET clarity allows for easy integration of the content, while its barrier characteristic protect against moisture and oxygen, extending the shelf life of medical supplies. Benefit of PET. PET offers exceptional mechanical strength and toughness. Structure incorporating PET component can withstand heavy load and resist impact, reducing the need for repair. Other than that, PET is a lightweight polymer, making building components easier to handle and install. This improves construction efficiency and reduces labor costs. PET provides excellent thermal insulation, reducing heat transfer and lowering energy costs. Comfortable indoor temperature are maintained, reducing reliance on heating and cooling system. Besides that, PET exhibits exceptional moisture resistance, preventing water penetration and mold growth, ideal for areas like basement, bathroom, and exterior cladding. Lastly, PET is highly recyclable, contributing to waste reduction and resource conservation. Recycled PET can be used in construction materials, supporting a sustainable industry.
Criteria in testing mortar. For fresh mortar testing, it focuses on three main aspects, which is consistency, setting time, and air content. Consistency. This determines the workability and ease of application. Tests like the flow table, slump, and flow cone measure the flowability and plasticity of the mortar, ensuring it can be shaped without segregation or excessive bleeding. Setting time. It refers to the time it takes for the mortar to change from a plastic workable state to a hardening state. Tests such as the Vickers apparatus or penetration resistance determine the initial and final setting time. These tests help with scheduling construction activities and ensuring proper handling and finishing of the mortar. Air content. The presence of air in fresh mortar can affect its workability, strength, and durability. Air content tests like the pressure or volumetric method measure the volume of entrained air in the mortar. The desired air content depends on the specific application and type of mortar used. For hardening mortar testing, it focuses on four main properties: compressive strength, structural strength, water absorption, and bond strength. Compressive strength. The properties assess the load-bearing capacity of hardened mortar. Tests like mortar cube test measure the maximum load the mortar can withstand before failure. Flexural strength. It measures the resistance of hardened mortar to bending or cracking under applied load. Tests like the three-point bending or modulus of fracture test evaluate the mortar ability to withstand bending stress. Water absorption. This test determines the amount of water that hardened mortar can absorb. Excessive water absorption can reduce durability and increase susceptibility to freeze-thaw damage. The test involves immersing mortar sample in water for a specific period and measuring the wet heat. Lower water absorption indicates better quality and improved resistance to moisture-related issues. Bond strength. It assesses the ability of hardened mortar to adhere to other surfaces, such as masonry unit or substrate. Tests like the pull off or shear bond strength evaluate the strength of the bond between the mortar and the substrate. Adequate bond strength is crucial for the structural integrity and longevity of masonry and plaster systems.
For the application of mortar in construction, used in masonry work, plastering, concrete repair, filling or patching, rendering, leveling floor, and creating precast items. Commonly used in bricklaying for joining bricks or blocks in construction projects, and it's used as a rendering material to cover and smooth road surface. It also fills crevices and space between bricks or blocks in measuring work and used in tile fixing. Some of advantage method in construction is efficient brick, stone, and block wall construction with pollen and blast furnace clay mortar. Beneficial for structures exposed to wastewater and corrosive with sulfate resistant and pozzolana protection.
Lastly, the research methodology.
For material preparation, based on the table that you see, percentage of PET that we use is 2%, 4%, and 6%. For each percentage, we use 3 cubes that will be produced with the ratio of 1/4 by using 50 mm cube size. For mortar material, first we use PET. We collect and clean before it can be ground to the same range size with sand. Second, we use cement. We use ordinary Portland cement (OPC). Third, we use sand with range of 0.075 mm to 4.05 mm. And the last one, we use water with water ratio of 0.4 to 0.6.
For chapter 3, I want to talk about data collection. For this study, two tests will be used in order to evaluate the strength of hybrid mortar, water absorption test, and compressive test. The tests are given. Each test are explained as the following subsection. I want to talk about it. Okay. First, water absorption. Water absorption test is a method to measure the amount of water absorbed by different materials under specific conditions. The material and equipment we use are sample of mortar, balance, beaker, stopwatch, carrying oven, and weighing scale. And the summary of procedure are these procedures involves preparing mortar samples, casting them into specimens, bathing them, immersing them in water, removing them, surface drying, and finally weighing them. The percentage of water absorption is calculated using the formula mass of the wet cube per mass of dry cube. The average water absorption for the set of specimen is also calculated, and for the second test, which is compressive strength, the compressive strength is a fundamental method for assessing the performance and quality of mortar. It measures the ability of mortar to withstand external loads or force. The material and equipment we use are only measuring tape and compressive machine. And the summaries of procedure are measure the area of cube samples, compress them in a compressive machine until they fill, and calculate the average compressive strength for the cube sample.
Okay, that's all from us. Thank you for watching. Bye.